there are a lot of what we call experimental probabilities. What binomials do is that it breaks down the probabilities into basically a yes or a no scenario. You basically wind up with two outcomes. What happens here is that you have n number of trials. Each trial has only two outcomes, success or failure. Success or failure. The probability of success is always denoted by little p. Okay. And then obviously the failure would be the complement to success. You can say it that way, but that's how it goes. So, really easy way to show you guys how this works is to do a quick survey, which means we need to put our heads down and close our eyes. Well,
just like go, hey guys, everyone back up for a moment.
I know you start drooling. All right. So let me ask. I want to ask you guys a question. This is yes, because I need you guys not to look at other people to be influenced by their answers. We're not playing heads up, 7-Up.
What?
Did he put his thumb out?
He did, yes. And he's laughing. He's ooh. Sorry. Don't look. All right. Put your heads down. Cover your eyes. I'm going to ask you a question. The question is going to have a yes or no response to it. When I ask said question, if you say yes, you will raise your hand. When I say raise your hand, if you say yes. If you say no, you will raise your hand and say no. Do not raise both hands. You will not be counted twice. Okay? Stop snoring. Anyway, my question is, do you believe in UFOs? Raise your hand. Beatmeyer, put your head down. Do you believe that there are extraterrestrial beings flying around somewhere in the universe? Raise your hand if you believe yes. All right, so last call for yes. Wait, leave them up. I gotta count. Then that means the rest of you saying no. Raise your hand if you believe no. Okay. Now you may lift your heads up.
I couldn't decide. I really couldn't either. Because I've never really thought about it.
When you say if you believe in UFOs, that doesn't really work because UFOs are just unidentified flying objects. So something just got thrown, you wouldn't know what it was.
It's pretty evenly split.
I mean,
Come on, my kid!
He's out. There are
we only have 16 people in here?
2, 4, 6, 8, 10, 12, 14, 16, 17.
Someone didn't vote.
Who didn't vote?
Emma, oh my gosh. I didn't vote.
That's right, Beamer, you didn't vote.
Did you not vote? No, I didn't vote.
All right.
I did vote. You messed it up. I voted no.
Did I count wrong?
Yeah.
Oh, we have to redo it. New question.
Yeah, let's do that.
Who likes pizza?
All right, new question.
Sorry.
Are you serious?
Put your heads down.
We'll make this real quick.
We can have naps now.
All right, just close your eyes. Close your eyes.
I can't.
Who thinks Beatmeyer is a moron? Raise your hand. Are we using this one? So we'll just say 16 of us and whatever. So what that means is that we have a probability that 7 out of 16 of you believe that there are UFOs. Give me a decimal for that, please.
7 divided by 16.
I will assume no.
Did you just say that you were bullied? Did you seriously say that you're bullied?
So we'll say it's point.
It was actually right.
Yeah.
We'll say 0.44 just for argument's sake. Now, that means 0.44. What would the, if that is our p-value, that's success. What would the 1 minus p equal? 0.56. Okay. Now, oops, wrong button. Wrong button. One of these. What this allows us to do then is to set up something, oops, where I want to ask the question, what is the probability that I exactly 5 of us believe in UFOs? What's the probability that that randomly selected 5 of us out of the 16 believe in UFOs? This is where what we call a binomial distribution probability comes into play. Because what we're looking at is the probability that we select exactly 5 people that believe in that out of our random sample of just 16. Okay. This is, it sounds like it's going to be horrid. No, it's not, because it's not that simple. What's happening here is that we have to go through different combinations, and you have to think about the probability of selecting a person that believes it, and then having X amount of people going with it. Ask the people with tinfoil hats. Yes, we can do that as well. So here's what we get. We use this formula called binomial distribution. Now, hold on.
That's ugly.
Oh, that's beautiful.
I wasn't bullying you, I just said that.
So if I want to say the probability of exactly 5, what we have here is n
It's a lot of
successes? Yes. N trials, 5 successes, probability, and so on. So here's what we get. Our N is the number of trials. K, number of success. P is our, in our case here was 0.44. And so on. So when we're talking, when we had, we wanted to have, out of our 16 people, that's our number of trials. The number that we're looking at is we have 16 people in the class. We want 5 successes. It's a matter of putting it together then. 16 choose 5 times 0.4 to the 5th power times 1 minus 0.4 to the 16 minus 5. And it winds up being a lot of calculator work. It's about playing a shot. Now,
No, it's like, okay, so 16 trials, because there's like.
Yeah, what's the letter?
N.
Okay, good. I got confused. I thought it was L first.
This attitude needs to like go away. Wait, it's times 0.4?
yeah.
What? Then go to bed, nobody's stopping you.
The probability that we randomly select 5 of us out of the 16 that believe in the UFOs would be 16%. Interesting. it's kind of interesting as you get into that. So what we can do then is there's actually a button on your calculator that does this. Of course there is.
There's always a calculator button.
Hit math
7.
probability. No, oh, I hit the wrong one. It's under,
Random binomial.
no, it's not that one.
What's the name of it?
I gotta find it. It's under stat then. That's right there. Where is it? I forgot where it is. Bless you. I forgot where it is. It's Bino PDF, Bino CDF. So, where is it? You're looking for something that says Bino PDF.
Wait, you can do like the random numbers and stuff on the calculator?
Yeah.
Toss coins.
Where is it? Is it distribution?
You can toss a coin on the calculator.
There it is, Bino PDF. Okay, hit second distribution. There are two options here. We have one that's called Bino PDF. There is a Bino PDF and a Bino CDF. Our Bino PDF button allows you to calculate exactly 5 out of 16. You want to know what's the probability of selecting 5 people that believe in UFOs out of the group. The Bino CDF is cumulative. It adds up values. It's for helping to figure out at least, at most. And I'll show you that here in a second. So if we type in this Bino CDF button, and what's it? So it's second bars, option A. Oops. You can just type alpha A. I'll get you to it. You get Bino PDF. Everybody see that?
Yeah.
Now, in our calculations, we had 16 trials. Our p-value is how much? 0.44. Our x-value, how many successes did we want? 5. And it comes up with that. And it types it in. What's that? What did it give us?
It gave us like 12. Yeah.
That's fine. All right, so we use 0.4. So if we use 0.44, let me just see if I can edit that real quick. We should be able to overwrite it. Yeah.
Wait, what'd you put in for X value? 7?
No, 5.
Oh.
There it is. Sorry. So if you use 0.4, because I accidentally typed in 0.4 as opposed to 0.44, you get the same number. Okay? Should have been 0.44, but I made a boo-boo. Story of my life. Making mistakes since 19, whatever. Not that old. Sure.
You can roll dice on here too. He was born in the 60s?
Nah, I think it's more like the 80s.
80s?
Yes, I was born in the aughts.
I feel like he's like 36.
He's a baby boomer.
I'm 36. Baby boomer. All right. Let's use this next example out of the book about how it works for calculating upwards.
This is so weird. I didn't know that you could do all these things on calculator.
So much. Really
Why didn't you tell us we could play games on the calculator? We've been playing games on the calculator all year.
You have to program it.
Not for this.
You can roll dice.
It's not a game. That's just a probability.
Oh yeah, there's probability stats.
You can like roll dice and toss coins.
It's
And
not a game.
It's not a game. Overtime, I wouldn't
hey, it could be
I
fun.
guess.
You can draw numbers for the lottery too.
Where is that?
You can also draw paper
You can draw cards.
Let me show you a little what you can do with this.
What? Okay, you go to apps and then.
Binomial distributions, you generally create what are called histograms. Histograms are bar charts, okay? As we get numbers of trials being larger and larger and larger and larger, histographs tend to norm themselves out, and that's where that normal curve comes into play. What happens though is that if I'm looking at, this is the example straight out of the book here. If I'm reading it through with the example with the book for the probabilities, now the probabilities they came up with, their random sample was 37%. Ours was pretty close at 40 something. So what they're saying here is they've calculated that Bino PDF the long way 7 times. What's the probability you select nobody that believes in it? What's the probability you select that one person, 2 people, and so on out of their number of trials?
So when did you do Bino PDF and then Bino
Get into it. Bino PDF is for when we want exactly that number of persons. So out of the, let's say out of the 6 people believe in UFOs, I want exactly 3 people to believe in UFOs. The probability that I select 3 out of the random sample of 6, out of the sample of 6, will be 25%. What we did was, what's the probability of the 5 out of our classroom of 16 that believed it with our data? Now, what I wanted to do is, what's the think of it this way. I'm going back to the book's example, where their p-value is 0.37, their number of trials is 6, and we're looking at k successes. Now, if I want to think of the probability of getting at most 2 people believing in it out of the 6, that means nobody can believe in it, 1 person can believe it, or 2 people can believe in it. Do you agree on that? Which means I would have to take there and calculate 0, 1, and 2, and add them all up. Okay? You can do that, or you can use what's called the binomial CDF function. The binomial CDF, think of it as cumulative. It's going to count up to a certain value. So if we do this correctly, we go back to our calculator, second bars, and I think it's alpha B, because they're all the shortcut keys. We have number of trials. I'm going to use the book example, 6, p-value 0.4, oh, I'm sorry, 0.37. And the x value here is we want to go up to 2, I believe. So it should be able to go, if I hit 2 here, the Bino CDF then is going to add up those probabilities up to and including 2, if I'm not mistaken. So 0.606. So if I look at this, if I add these together, just these 3, 6, 0, 6. See what it's doing? It's adding up, starting at 0, up to that number that you put into it. Okay? So your Bino CDF, the Bino CDF function, will count the number of successes from 0 to whatever you want. That's when we start talking about at most, at least. Now, if I wanted to say at least 2 people, that means the floor would be 2, and I'd be going up to 6. So if I do that, wouldn't I just want the complement stuff? I can use 1 minus it. Let me rephrase that. I'm looking at this again. What's the probability of at least 2 people believing? The probability of at least 2 people believing would that include 2? It would include 2. And it would be from here to here, wouldn't it? Now, wouldn't that be the same as taking 1 minus less than 2 believe? Is that the same? Because shouldn't all these probabilities add up to equal 1? That's the idea. Remember how we used complements for when we rolled 2 die, or 2 dice? Then you would see how, instead of what's the probability of rolling not a 5? Well, you just add up the 5s and the other ones were not 5s. It's the same basic principle. Okay? Bino CDF adds up to a certain value. Bino PDF is the exact value. Try not to get too crazy with this. So let's look at an example. We don't. Question. So let me look at these two. Calculate the probability of successes for binomial experiment consisting of n trials, probability of p with so many successes. First example says k is 7, number of trials is 12, p is 0.7. Is this a bino PDF or a bino CDF for that first one? Which one would you use? PDF or CDF? PDF. PDF because it's exactly 7 successes. So I would put in my bino PDF. And what's nice is that after you have a couple of these in your calculator, all you have to do is go back up to one of them, hit enter, and then just overwrite it. Does that make sense? It's a lot easier than trying to find out where everything was. So if I have my number of trials is the first one, so it's 12. Oops, not 112. 12, comma.
What's wrong? I'm confused what the difference is.
PDF is exact number. You want 7 successes. CDF you want at least or at most, or fewer than or greater
You're
than.
in the wrong place. No, I did not. I didn't say it.
So the probability that I choose 7, exactly 7 people believe in something out of 12 with a 70% success rate is 15.8% chance that works. All right, that's how this works. Now, the other one is your CDF. What I want you to think of is you've got 14 trials, so you can have success at nobody, 1, 2, 3, 4, all the way to 14. You okay with that?
Doesn't it just say, oh.
And I want successes that are less than or equal to 3. Now, bino CDF adds from 0 to whatever k value you select. So in this case, when I'm trying to add from 0 to 3, do I need to do 1 minus it? No, because it's going to add up from 0 to 3. If I wanted to be greater than 3, that's what I would do the opposite. Bino CDF, Bino PDF, exactly that number. Bino PDF or CDF, I keep messing these up, I'm sorry. Adds from 0 to k. This is kind of the fun stuff. I'm just barely talking about it. I'm giving you enough of it just to make you cry. Nah, not cry. Okay. So let's do these. I don't think that's all I want, but I think it might be. what's great, that there's a couple of questions on here. What is the probability of guessing correctly on multiple choice tests?
Oh my goodness. I still get really bad at those.
25%, yeah, like, yeah, right now.
So if you think about it, binomial, if you think about multiple choice tests, if you have four answers,
And you pick the one with high.
what's the probability of guessing the right one? 25%. So your p-value would be 0.25.
What's the probability of guessing every single question?
All right, this is how we do that. If you have a 50-question test and you want to get 50 of them correct, your probability, you want to get exactly that number correct. So that would be a bino. Is it a PDF or a CDF?
PDF.
Bino PDF. So we go to our calculators. I'll do the second bars. Alpha A, that's my bino PDF. I have number of trials. I have 50 questions. The probability of guessing one correct is 0.25. How many do I want to get right? 50 of them. So the probability that I get 50 of them right is a snowball's chance in HE double hockey sticks.
But it's still a chance.
There's still, what you're saying, there's still a
You're
chance.
telling me there's a chance.
So you're saying there's a chance. So 7.88, so I gotta move it over. 1 little, 2 little, 3 little zeros, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 22, 23, 24, 25, 26, 27,
I say it.
28, 29, 30, 31, 30, 31.
There's a chance, I don't know.
Wait, that's your chance of getting all 50 correct?
If you guess random.
If you guess
Well, you have to take in logic.
Oh my goodness gracious.
I honestly didn't think it was going to be that low.
How? What did you expect?
Now, what if you wanted to what if you just want to randomly select just enough to get a C? Oh wait, that wouldn't work because you still have to answer all the rest of the questions.
Yeah.
On a multiple choice test though, out of how many of those 50 questions do you really have to randomly guess?
Not that many.
4 or 5?
Hopefully.
Now, let's say in that idea that you have 50 questions. Well, the number of questions you have to actually randomly select. Let's say there's 8 questions on a test that you had to guess on,
That's pretty bad.
and then
Wait, isn't it 50 trials? X value 8?
no, and that's why I'm changing it because we're taking out the 42 questions you knew how to do. So let's say there's only 8 questions you had to randomly guess at, and then it's just 8, and you want to get all 8 of those right.
Oh, okay.
There's no pretty low chance.
Still not that great.
Oh my gosh, that's so
But then you have to
And that's where Sawyer, and I'm gonna give him credit, that's where he made sense. Use logic.
It's like 0.000%.
A lot of times when you're looking at multiple choice tests, if you use logic and reasoning, you can figure out what they're asking.
Yeah.
What if they
And
don't
usually-
have like common sense?
I
mean, Sawyer
think
has it,
Common
so-
Sense is on sale at Target this weekend.
That's sort of But like that, you have to also add in like, oh, I know it's not this one, so that's like what
Well,
3 chances.
Right,
that there's,
right,
like,
and then-
1 in 2 chances.
And a lot of times, as you get, and that's why it's great about if you take more of the ACTs, take more of the SATs, because there's a lot of stuff on there that you're not going to remember at all. But if you use enough of the logic of just enough information to get it right, you'll be fine.
It's more. It turns into more like a 1 in 2 chance.
Yeah. I think I told you guys this a couple of years ago. Seb and I, about 3 or 4 years ago, we had somebody erase or block out all the questions on a geometry test, a final, and we just looked at the answers. And we just read the answers and look at how, how a lot of answers are very similar and something doesn't look right and all that. We went through and just took the test via the answers. Took a long time to do that because you're really trying to figure out what could go wrong and just working backwards from stuff. I think we both got C's.
I can't even get a C when I have a problem.
Well, there's the problem.
You only looked at the
Multiple
answers.
choice?
Yes.
Dude, I'm really nervous. I'm just bored because it's so
Then
easy.
Do you guys want on the review packet, want me to make it multiple choice?
Yeah.
I can, for a lot of the questions, I can do that. I can do that for a lot
I
of
don't
them.
think it really matters, cause you
Or-
still wanna know how to do a question.
Then
With the
you're
Bible, is
practicing
the
guessing,
Bible
so.
Can you do multiple choice?
I can mix it up.
Or like maybe do like
Put
a
some.
version without it and a version with it.
Mm-hmm. I can mix some stuff up.
Yeah.
That shouldn't be that, it's not that tough to do.
I hate multiple
Okay,
choice.
guys.
Wait, no, I like multiple choice and everything but math.
Math is hard with multiple choice. It really is.